Hey guys, welcome to my channel. I know there's a lot going on and that we're all stressed and stuff, but I think we should make the best use of like this long time that we have now and like try to do something productive out of it and take our minds off of things. So whether you're watching this in order to prepare for like next year when your studies come, or if you're watching this in the future, either way, I basically want to try to teach this sort of topic. And the reason why I want to do that is because I don't think like schools teach this very well. Like you just sort of accept this as a formula, but I think there's like a very nice like a geometrical, like a visual meaning to it, which I don't think people really teach. So that's what I kind of want to do here, so that you can sort of have that sort of understanding. So if you guys don't already know what dot or scalar product is, it's basically just this formula. So if you have two vectors, you have A and then you dot it with vector B, then you say that that is equal to the modulus of A times by the modulus of B, and then times it by cos theta. And this theta is the angle between the two vectors. Now if you're seeing this for the first time, or when you saw it for the first time, you'd probably be like, what does that like mean? Like I don't know what this means. So in order to think about it, let's consider like some random 2D space, okay? And then I just want you to think about a random vector there. Imagine that vector I'm gonna call A. Just a random vector in space, I'm gonna call that A. Now if I ask you to work out what the horizontal component of that vector is, what would you do? Hopefully you would realize that you can say this angle is theta, and you can say that the horizontal component, which is this, is going to be A cos theta. Hopefully we can all see that, and hopefully we all know that. Now if we know that this is A cos theta, well, look, that is already looking a bit similar to what we have in the formula, isn't it? It's already looking a bit similar to what we have in the formula. Now what does that B mean then? Well, actually before that, why is it modulus? Well, remember this is vector, right? So vectors, how do we write vectors? We write it as like let's say 3, 4. But remember, all we care about here, it's not like a vector form. We just want a number at the end. Remember, dot product only gives like a number at the end. So we take like the modulus of this, and that would just give us the magnitude of A. And that's all that we're really going to care about. We're only going to care about like what the modulus of A is. We don't really care about like what the direction of A is or anything like that. We just want to care about what the modulus of A is, what the size of A is. So so in order to see where B comes from, well, let's think about it. What if we have a vector here? Remember, we do have a vector here because this is like the x-axis, isn't it? If this is like the x-axis, then we're going to have a vector here, and that vector is going to be like I hat. That vector there is going to be I hat, isn't it? I hat. But for the sake of this question, I'm going to call it vector B. So then what would modulus of A cos theta, actually let me do it right like this. We know that the modulus of A cos theta gives us the horizontal component of A, and if we times it by the modulus of B, and we know that B is just another vector over here, we're just timesing that horizontal component by the length of B. So in other words, what we're doing is, if B, instead of being the unit vector, it could have been like any vector, then all we're doing is projecting the vector A onto vector B, and then we're multiplying the projection by the length of B. Can you see that? So we just have a vector A, and we're just projecting it onto this vector. We're just projecting it onto that vector, and then we're multiplying it by the size of this vector, by the size of that vector. A cos theta is the projection of A onto B, and then we're multiplying it by the length of B. So some of you might be wondering, like, okay, that's great when it's like on the x-axis, but what if you have like two vectors, like just randomly like that? You can, so if you were to do let me just draw it a little bit better. let me just, if you have like a vector like that, then how do you know what the what it is like? How do you know that's to a projection? Well, remember this a cos theta, this theta is the angle between the vectors, isn't it? So, and also remember that your axis here, your x and y axis, is just a bit random. Like I can make anything my x-axis. I can make anything my y-axis. I can make the origin whatever I want. These are all like arbitrary things that we just define. So we can always just make like the axis along one. We always just make the line that one of the vectors is on, like the x-axis, and then we can make the other one the y-axis. So we can just make this the x-axis, and we can make this the y-axis. There's nothing wrong with that. The axes are just always just an arbitrary thing. We can define however we want. And if we define the x-axis the way along one of these vectors, you can see that from here to here, we just rotated it at 90 degrees. Not exactly 90 degrees, but we just, if you take this and if you rotate it in this direction, if you rotate it like that, we're going to end up with this. And again, so if we reverse that transformation, we would get back to this. And from here, you can still see that it is clearly just a projection. This is also the reason why, if we project two perpendicular vectors, so imagine if we have that axis here again, so if this is x-axis and y-axis, and say we have a vector here called b, and we have a vector here called a that is perpendicular to b, well, what would happen if we project a onto b? Well, look here what happened. You know, the projector, we had to we had to work out like the horizontal component, or the component of a in the direction of b, isn't it? But if we work out what the component of a is in the direction of b, well, that's just going to be this one point. And remember, a point is like 0 dimension. It doesn't have any size, so that point would have the size of 0. So a cos theta would become 0. If a cos theta becomes 0, then, and because it's whole multiplication, the whole thing would become 0. So some of you might be wondering now then, if you remember, if you do like say 3, 4 dotted with like say 1, 2, in order to actually compute the dot product, what you do is like 3 times 1 plus 4 times 2. That's what we do in order to get the dot product. So when we're not using this formula, this is what we do. So you might be wondering then, how does this relate to the projection? We know now that a b cos theta, modulus of a modulus of b cos theta relates to projecting a onto b. But then how does that and this is the same thing? They are like completely different things. Well, you are right about that. And actually, to explain that is actually very long, and this video is already kind of long. So if you want to know why that is the case, then you can watch this YouTuber called 3 Blue 2 Brown. You might have heard of him already, and he made like a very good video explaining why the dot product, like multiplying them and adding them together, relates to the projection. And if you watch that, hopefully that would make more sense, and he probably explains it better than I could, because he animates it and things, and he explains why multiplying it and adding it together is the same as a projection. So okay, so that's it for this video. Hope you liked it. If you did, please give it a thumbs up and subscribe to my channel, and leave in the comments below what you'd like me to teach next. I'll try to see if I can do that. And thank you all for watching.